Hello students, today we are going to discuss sequence detector in the course Digital System Design. So a sequence detector is like a bit stream is given to you, and in that bit stream it can be 100, 1001, so on. And in that bit stream the question will be like detect a sequence of 1001 and give the output in that case 1. So for the corresponding input we will see here 1001, the output should be 1 once the sequence is completed, and again 1001 once the sequence is completed. And now here you see the 1001 and the 1001, the last one is shared between the two sequence. So if you have to share this one from the another sequence, it will be called as overlapping condition. So if you consider the overlapping condition, the last one can be included, last one or whatever bit that is required from the previous one. Let's say you have to detect a sequence of 111, and if you have 11111, so how many times the sequence will be 1? So first, for the first 3 the sequence will be 1, output will be 1, and if you can include, it is 1 sequence. Another sequence will be like including the 2 ones from the previous one and including the third one. So again the sequence will be 1, and for again 1 2 3 ones are deducted like this, so sequence will be 1. So number of bits can be included if the overlapping condition is there. You can include the bits if it is useful to detect the sequence again. So in this overlapping condition you can see the sequence is can be made if you include the previous bit from the last sequence. So it is called as overlapping condition, and for this condition the sequence can be detected like this and output can be 1, and for all the rest conditions the output will be 0. All right. All right. And if there was a non-overlapping condition, the sequence will be like 0001 because the first sequence is deducted here and another sequence is deducted here, and this sequence will not considered as the sequence because it is a non-overlapping condition and we cannot include the previous bits, so output will be 0. It can be made by it can be made by using mealy machine and mooore machine. In mealy machine, number of states will be equals to number of output. State equals to number of bits in sequence, and in number of states of mooore machine equals to number of bits in sequence plus 1. Alright, so let's make a sequence detector for 1001 using a mealy machine first. And the condition is overlapping. Okay, so for designing any state diagram, first you have to make an idle state. Now the first bit of the sequence is 1, so that if the input provided is 1, the sequence will be S1, and if the input provided again is 1 and then 0, then the output will be S1 0, and again you need S1 0 0. As we are looking for the sequence 1001, we are going from idle to, we need an input 1, so this is the input, and the output corresponding to that is 0, so output will be 0. And if we move from S1 to S10, the input will be 0, because you need 0 after 1, so 0, and output corresponding to that is also 0. And again, if you move from S10 to S100, you need an input 0, and output corresponding to that is also 0, because the output will be 1 only if the sequence is detected. So after there is 100, now here you can see that there are 1 2 3 4 4 states, and in mealy machine the number of states is equals to number of bits in the sequence, so number of bits in the sequence is 1 2 3 4, so that's why the number of states in the mealy machine is 4. So after that 100, there can be two conditions, that 100 our next input is either 1 or output is 0. So if the output is 1, input is 1, the sequence is completed. 1001 is our sequence, and it is a non-overlapping, it is an overlapping case. So the procedure that you can follow here, the trick you can follow here, is to look for the last 3 bits of the sequence. It is 001. And now look at the states. Is there any state that contains 001? It contains 1, it contains 10, and it contains 100. So it doesn't contain any 001. So now we will look for last 2 digits. It says 01. Is there any bit, any sequence that contains 01? No, there is not. So now we will look for the last digit, last bit. It says 1. Is there any state that contains 1? Yes, there it is 1. So it will move to that state, and the output will be 1 comma 1, as there was 1001, so the next input was 1 and output will be 1 because the sequence is not detected. Now there can be another case that 1001 1000 was there. So in this case also we will see the last 3 bits. It says 000. Is there any state that contains 000? No, there is not. So we'll look for last 2 digits. It says 00. Is there any bit states that contains 00? No sir, there is not. So we will not see any states either. Now we'll see the last bit. It says 0. Is there any state that contains 0? No, there is not. So it will move to idle state. It will restart. Okay. And similarly, for S10, there can be 2 cases. For S10, there can be 2 cases, either 100 or 101. Now you see here, once there was 100, it moved to the next state, so it is done. For 101, what will be the, where it will go to the next state? It will be going to, you have to see the last 2 digits. It is S01. Is there any sequence that has 01 in it? No sir, there is not. So we will see for the last digit. It is 1. Is there any state that has a 1? Yes, there it is, S1. That will move to S1 if there will be input 1 and output corresponding to that is 0. and if we move to S1, it has 1 0 or 1 1. So when there was 1 0, it moved to the state S1 0. But if what if there was S1 1? So at 1 1, you can see again the same thing. You see the last two digits, or is there any 1 1? No, there is not. Is there any 1? Yes, there is. So it will move back to itself at 1 comma 0. And it's similarly at idle state. For the sequence to start, you have to see S1. You have to get input 1, so it moved to the 1. What if the output input was 0? So at 0 it will be 0. So where is 0? And it is in idle itself. So idle 0 comma 0. So not is the state diagram of a sequence for 0 0 1 0 0 1, and considering the overlapping case and using mealy machine. And now we will also see sequence 1001 for non-overlapping condition using mealy machine. So in mealy machine, the basic difference is it has a more number of states than mealy machine. It has n plus 1, and the output corresponding to that is not dependent upon the uh, next input, but it is the state that decides what will be the output for that condition. We will see for idle the state will be like this. So we will make the same thing as one following S1 0 and S1 0 0, and the last one will be S1 0 0 1. 1 2 3 4 5. So number of bits plus 1 5. Okay, so the basic difference in the Moore machine with the mealy machine is that the state has its output in itself. So for that, in this sequence the output is not completed, that's why it has 0 output. And here the sequence is completed. 1001 1001 is our sequence, that's why the output will be 1. It is a Moore machine. Here we have already entered the output part, so we have to only enter the input part here. So the input says when the machine was in idle state, when the input 1 is received for the sequence, input 1 is received, it will move to the S1 state. And when the input is 0, once we have received input 1 and it has received a 0, it will move to the S1 0 state. So the input will be, when input will be 0, it will move to S1 0. And again, what will be the input here? As it was S1 0 and it has moved to S1 0 0. So 1 0 is added, so the input will be 0. And what will be the input here? From 1 0 0 to 1 0 0 1, the input will be 1, right? And here my two cases will be arising. 1 0 0 1, the next input will be either 0 or 1. 0 or 1. Now here the same thing will be following. We will following that we have learned here. You have to look at last 3 or 4 digits, whatever will be the input. The maximum thing is here is the number of bits is 3, or you can say 4, but we have to look at 4 digits. Let's say we are looking for last 4 digits. It is 0 0 1 0. So 0 0 1 0. Is there any state that contains 0 0 1 0? No sir, there is not. So we'll look for last 3 digits. 0 1 0. Is there any state that has 0 1 0? No, there is not. So we will look for last 2 digits. It has 1 0. Yes, we have 1 0, but that is for an non-overlapping case. So if we had an overlapping condition, so it will be moving to the S1 0 because 1 0 is here. So but non-overlapping condition, which means that it should not use the previous bits from the next state, from the previous states. So once the sequence is deducted, you need to go back to the idle state for a non-overlapping condition. For a non-overlapping condition, you have to move back to the idle state. But if the condition was overlapping, then you can move to S1 0. So for either 0 or it is 1, it will move to the same. No, it will, once the output is 0, we were looking for when the input is 0. So what if the input is 1 again, S1001 and again 1? So in this case you can see the fresh 1 bit is available, so it will move to the fresh 1 bit, that is this state. So for this state, okay, now for this state two inputs are given, and the states are determined whether it will go to 0 or whether it will go to idle or any other thing. Similarly, we will find for 100 100, again it will be either 1 or 1000. So for 1001 it has already moved to the next state called 1001 as 1001. For 1000, where it will go? So it will look for last 3 digits 000. Is there any state that contains 000? No, there is not. So it will move for last 2 digits which has 00. Is there any state that has 00? No. Is there any for the last bit? There is 0. Is there any state that has 0? No, there is not. There is 10. There is not 0. So it will move to the idle state, that is at 0. Similarly, at S10, the next input will be 100 or 101. Right. So for 100 it has moved to the next state called S100. For but 101, there is there any state? There is not. So if we look for last 2 digits, last 2 digits says 01. Is there any state that has 01? No, there is not. So is there any state that has 1? Yes, there it is. So it will move to the 1. Similarly for S1, either it can be 10 or it can be 11. So for 10 it has already moved to the state as 10, and for S11 it will look for any state that has 11 in it. There is not, so it will look for last digit. There is S1. Yes, there it is S1, so it will move back to the S1 itself. And for the idle, it will move back to itself and then put it 0. So that's how you design a mealy and mooore machine for the given sequence, either for overlapping case or for non-overlapping case. Thank you.